So we're doing 3.5 today, compound Boolean expressions, and then we're also going to learn how to do a truth table. Some of you may know how to do that already. We have two Boolean operators. Double ampersand means and double vertical bars means or. And the vertical bars is shift backslash. In case you don't know where it is. On some keyboards it shows as a vertical line with like a cut in it, but when you type it, it's always a vertical bar. So two of these ampersand signs means and two of these vertical bars means or. So I'll show you an example. I'm going to make some Boolean variables. Boolean very hot equals false. Boolean very windy equals true. See, I wrote this back when we were maybe going to have a power shutoff. So hot and windy. If very hot and very windy, system.out.println red flag warning. So I'll run this. We shouldn't get anything printed. So this is an example of doing a compound Boolean statement. Remember, with Boolean variables, you don't have to say, it's not wrong to do this. I could say if very hot equals true and very windy equals true. That's the same thing as what I had. So I'd like to encourage you, when you know you're working with a Boolean variable, Cassius Megas, you guys are on task? You're also recorded forever in this video that will be on the internet until the end of time. But I'm glad you said you were ready. So there's no shame in saying, yes, I'm ready, forever. I'm just trying to explain what's going on here. We're checking if very hot is true and very windy is true. And if they're both true, then we print red flag warning. So I'll make this true, and we'll see it work. We'll run it. So this time we got red flag warning because they were both true. So they're all inside of one set of parentheses. Why don't we add that note? Put conditions with operator in a single set of parentheses. So see right here, we have one set of parentheses. And then we've got that and thing going on. So red flag warning, in terms of fire danger, it's got to be hot and windy, not just one or the other. That's why we did an and. I've got another scenario. No, different topic. Boolean car available equals true. Boolean can walk equals false. If car available or can walk. So for this one, I made two new variables, one called car available. That means like there's a car I could use. And there's another Boolean can walk. Right now that's set to false, but that would be could I walk to my friend's house? So either there's a car available for me to drive to my friend's house, or my friend lives close enough that I could walk, like it's not 20 miles away. Then so let's predict. Will this print I can see my friends, or will it not print I can see my friends? It will. The way an OR condition works, this is an OR. The way an OR works is if either one of these is true, it'll trigger the whole condition. So let's red flag warning, I can see my friends. I'm going to remove the that one because we're not really doing that. They're unrelated. So I can see my friends in this case because the car is available. And if I set that to false, then we have this or condition. Nothing will print because one of these has to be true for this whole condition. Yeah.
And if you have an else, like you can't do anything, would it print that?
Yeah. So let's throw an else on. Sorry, stay home. So let's run this. We're going to get sorry, stay home. But see, if there's a car available to borrow, or you could walk to your friend's house. I'm going to say that you could walk. This time it's a friend who lives close enough to walk. Then you can see your friends. Yes, so none of these compound things can be used with an else and an else if and all that stuff. So this is called a compound Boolean expression because there's more than one thing going on. You could add way more than just two. And you can use parentheses. You can have more than two conditions. You can use parentheses to group them. It's kind of like order of operations with an algebra expression. The stuff inside parentheses will get evaluated before stuff not in parentheses. And I have one other twist on this. You can do all of this with nested if statements too. So it doesn't have to be, you don't have to do it this way. And I'll show you what I mean. You could say if car available, and then you could say right here, if can walk. And then I'm going to get rid of the else because it gets a little... But this is the same thing. If car available... no, it's not the same thing. But it's close. This would be an and, right?
Yeah.
So it's not the same thing. Bad example. It would have worked if this was an and. So it's not quite the same thing. But if you're doing an and, instead of all of this, why don't I say you could do some of this with nested if statements. So this would be that you need a car and you actually have friends. We'd have to change the variables. I've got a car and I've got friends, therefore I can go see my friends. But this would be an and. So I wish I still had my hot and windy thing, but I deleted it.
Can't you just like Control Z?
Yeah, but I'd have to Control Z for every word or character I typed for the last 5 minutes, and I don't feel like it. So yeah, so for an or, you can't just, in my mind, I'm not thinking of a way to do this. I mean, you could add an else and an else if and stuff like that. Okay, I'll go right to here and say my examples. Cassius, Hunter, Megas, are you guys following? My examples didn't use braces because I only had single lines. Remember, braces really help keep things straight if things get complicated. All right. So now we're going to do truth tables. So truth tables, I'm letting you write this down, and then we'll do truth tables. How many of you did truth tables like in math class or some other class? Okay. Awesome. Don't feel bad if you haven't done it before. I'll teach you how to do it. Are we ready? I'm going to open up this, and I'm going to make a table. I want 4 columns and 5 rows. And let's make it like that. Sweet. Listen, everybody, a truth table. Whoops. Probably like to have a little title here. A truth table is something we use to help evaluate a logical expression. In this case, we can use them to evaluate a Boolean, conditional Boolean expression. All right, so we have 2 conditions. We're going to call them A and B. And a typical truth table, I'm going to line this up. A typical truth table starts with a true, true, false, false under the A column.
If you have 2.
We have 2 conditions. We have A and B. A is one condition, and B is another condition. And then down the B column, we're going to say true, and then false, and then true, and then false. So these are all the ways you can have 2 conditions that you're going to evaluate. You know, we live in a binary world, binary where there's 2 possible answers. It's either true or false. Another alternative way to lay this out is with 1s and 0s. That's totally legit if you prefer 1, 1, 0, 0, 1, 0, 1, 0, where 1 equals true and 0 equals false. And what we're going to do here is I'm going to show you, I got to fix this column. We're going to evaluate the Boolean expression A and B using these values. So you remember, the and is true only when both things are true. So if A is true and B is true, then A and B, this column, is also true. So if you're not caught up with me, let's get caught up. If you need to scribble it on paper because you don't know how to make a table in your Google Doc or whatever, I understand. You don't have to make the table in Google. You could just tab over. But I understand that there's a little formatting issues. So for this, the way we read this is we say, if A is true and B is false, what do I put here, a T or an F? F. I'm reading across. So we've got A is true, B is false. So they both have to be true. Otherwise, the and condition right here is going to be false. So here's another one, a false and a true. We're going to have another false. And here we got a false and a false. And even though they're the same, they're not both true. So and means they are both true. Not that they're the same thing. I remember when I was first learning this, I thought, well, F and F are both the same, so and, do we do and say that? No, they have to both be true. So I'm going to show you the or, and then I'll ask if you need clarification. So A or B, and I'll select this column and fix it up. So walk through this with me. We're going back to the A-B columns. So we're looking, if A or B is true, then we want to put a true right here. And both of them are true. We only needed one, but yeah, we're going to say true. And then A is true, B is false, but only one of them has to be true to get to this or statement. And same with this A-B line here. We get to say true because the B was true this time. And then finally, they're both false, so neither is true. So we put that there. So this is a truth table. And I'm going to make a copy of it and show it to you with ones and zeros. So
You're like lightning McQueen on there.
so it's okay to use ones and zeros if you prefer. The one meaning true, the zero meaning false. But you need some kind of system. Sometimes I find it easier to read when it's just ones and zeros because the T and the F are similarly shaped. But if you make a really clear T and a really clear F, it's okay. And you can do really whatever you want. So we have another twist, and that is the not symbol. And oops. So this exclamation point, we already learned that means not, but let's deal with it in this context. If we got A is 1, 1, 0, 0, and B is 1, 0, 1, 0, then we can do not A. We're just looking at the A column here. Not A means do the opposite of whatever was in the A column. So if A was a 1, we're going to put a 0 here. We got another A1, we're going to put a 0 here. A is 0, we put a 1 here. Not a 12, but a 1. And A is 0 over here, so we put a 1 right here. And, not B would work a similar way. It's just the opposite of whatever's going on in the B column. So wherever there was a 1, we're going to put a 0. Wherever there was a 0, we're going to put a 1. Are we good? Anyone have a question? I'll have a chance. We're going to have a half sheet in a sec. We're going to go over it, and I'll walk around and help you if you need help when we're doing that. Sometimes it just helps to see it on a piece of paper, I realize. It can get more complicated, as you can imagine. I'm going to show you one more. You notice I'm always starting these things with the same A, B columns. So you should too. It's just 1, 1, 0, 0, and then 1, 0, 1, 0. Those are all the ways you can combine two things that are going to be true or false together. I'm going to make whatever I do here fit right here. So I'm going to A and B. I'm going to take the spaces out so I can fit more things. Not A and B. And we're going to add another column. So you'll have things like this. A little crazy. I might say, hey, do me a truth table for this. Not A and B or B. And you'd be like, what? But you can get there. You just got to go one little piece at a time. So if I gave you just this column here, this column on the far right, what you would do is look and see we've got an A and a B. So my advice is make a column that's an A and a B. And then you see we did a not on it. So then just make another column that has a not on that. And then we don't need a separate column for B. We already have B here. But I'll walk you through doing this. Like some of you might be able to visualize what's going on over here. And that's awesome. Then you have a different kind of intelligence than I do. I'm not saying it's better, but it's different. I can't visualize what's going on in that last column without doing the work along the way. So we're first going to do A and B. So right here we have A and B. If they're both true, we're going to say this is true. So this column would be a 1 and then a 0, 0, 0. Right? Because the only place where A and B are both true is right here. Otherwise, we've got one of them true, the other one true, or none of them true. And then now we're doing not that thing. So now we don't look at the A and B column anymore. We're looking at this A and B column. And we want to do the opposite of it. See that not symbol there? So we're going to do just the opposite. 0, thank you. 1, 1, 1. We're just doing the opposite of this column right here in this column. And then finally, we're going to evaluate this expression with B, and we're doing an OR. So right here, we're looking, hey, B is 1, this thing is 0. We're doing an OR, so we got a 1 here. And now we're looking here, B is 0, this is 1, so we're going to put a 1 here. And B is 1, and that thing's 1, so we're going to put a 1 here. And B is 0, and that's a 1, we're going to put a 1 here. So this is an example of a statement that apparently is always true, no matter what the inputs are. The inputs could be true or false or whatever. And sometimes, even on the AP test, they'll give you questions. They'll say, all right, describe this Boolean expression. And they'll say things like, it's always true when A and B are the same, or it's always false if A and B are the same, and things like that. This one I happen to just make one up on the fly that's always true. But you'll see. We'll practice in a minute. Yeah.
Isn't that like called tautology?
Maybe. You tell me.
Yeah, it is.
Yeah, I'm not going to say modus ponens and all that stuff because I never learned those words. But a tautology
I
means.
had to Google it because I
Yeah. You were like, I think I learned this.
from Wilson's class and I forgot it.
So it's always true. It's called a tautology.
Yeah.
Thank you.
I just Googled it, but like I knew it before.
So anyway, this is just a sample of a more complicated one. That's it for